Machine translation, sometimes referred to by the abbreviation MAHT or interactive translation, is a subfield of computational linguistics that investigates the use of software to translate text or speech from one language to another. On a basic level, MAHT performs simple substitution of words in one language for words in another. But that alone usually cannot produce a good translation of a text because recognition of whole phrases and their closest counterparts in the target language is needed. Solving this problem with corpus and statistical techniques is a rapidly growing field that is leading to better translations. Handling differences in linguistic typology, translation of idioms, and the isolation of anomalies. Current machine translation software often allows for customization by domain or profession, improving output by limiting the scope of allowable substitutions. This technique is particularly effective in domains where formal or formulaic language is used. It follows that machine translation of government and legal documents more readily produces usable output than conversation or less standardized text. Improved output quality can also be achieved by human intervention. For example, some systems are able to translate more accurately if the user has unambiguously identified which words in the text are proper names. With the assistance of these techniques, MAHT has proven useful as a tool to assist human translators and, in a very limited number of cases, can even produce output that can be used as is. The progress and potential of machine translation have been debated much through its history. Since the 1950s, a number of scholars have questioned the possibility of achieving fully automatic machine translation of high quality. Some critics claim that there are in principle obstacles to automatizing the translation process. History. The idea of machine translation may be traced back to the 17th century. In 1629, René Descartes proposed a universal language, with equivalent ideas in different tongues sharing one symbol. The field of machine translation appeared in Warren Weaver's Memorandum on Translation. The first researcher in the field, Joshua Bar Hillel, began his research at MIT, a Georgetown University MAHT research team followed with a public demonstration of its Georgetown IBM experiment system in 1954. MAHT research programs popped up in Japan and Russia, and the first MAHT conference was held in London. Researchers continued to join the field as the Association for Machine Translation and Computational Linguistics was formed in the US, and the National Academy of Sciences formed the Automatic Language Processing Advisory Committee to study MAHT. Real progress was much slower, however, and after the ALPAC report, which found that the 10-year-long research had failed to fulfill expectations, funding was greatly reduced. According to a 1972 report by the Director of Defense Research and Engineering, the feasibility of large-scale MAHT was re-established by the success of the Logos MAHT system in translating military manuals into Vietnamese during that conflict. The French Textile Institute also used MAHT to translate abstracts from into French, English, German and Spanish. Brigham Young University started a project to translate Mormon texts by automated translation, and Xerox used SYSTRAN to translate technical manuals. Beginning in the late 1980s, as computational power increased and became less expensive, more interest was shown in statistical models for machine translation. Various MAHT companies were launched, including Trados, which was the first to develop and market translation memory technology. The first commercial MAHT system for Russian, English, German, Ukrainian was developed at Kharkov State University. MAHT on the web started with SYSTRAN offering free translation of small texts, followed by Alta Vista Babelfish, which racked up 500,000 requests a day. Franz Joseph Ock won DARPA's Speed MAHT competition. More innovations during this time included Moses, the open-source statistical MAHT engine, a text SMS translation service for mobiles in Japan, and a mobile phone with built-in speech-to-speech translation functionality for English, Japanese and Chinese. Recently, Google announced that Google Translate translates roughly enough text to fill 1 million books in one day. The idea of using digital computers for translation of natural languages was proposed as early as 1946 by A.D. Booth and possibly others. Warren Weaver wrote an important memorandum translation in 1949. The Georgetown experiment was by no means the first such application, and a demonstration was made in 1954 on the APEXC machine at Birkbeck College of a rudimentary translation of English into French. Several papers on the topic were published at the time, and even articles in popular journals. A similar application, also pioneered at Birkbeck College at the time, was reading and composing Braille texts by computer translation process. The human translation process may be described as decoding the meaning of the source text, and re-encoding this meaning in the target language. Behind this ostensibly simple procedure lies a complex cognitive operation. To decode the meaning of the source text in its entirety, the translator must interpret and analyze all the features of the text, a process that requires in-depth knowledge of the grammar, semantics, syntax, idioms, etc. of the source language, as well as the culture of its speakers. The translator needs the same in-depth knowledge to re-encode the meaning in the target language. Therein lies the challenge in machine translation. How to program a computer that will understand a text as a person does, and that will create a new text in the target language that sounds as if it has been written by a person. In its most general application, this is beyond current technology, though it works much faster. No automated translation program or procedure, with no human participation, can produce output even close to the quality a human translator can produce. What it can do, however, is provide a general, though imperfect, approximation of the original text, getting the gist of it. This is sufficient for many purposes, including making best use of the finite and expensive time of a human translator, reserved for those cases in which total accuracy is indispensable. This problem may be approached in a number of ways, through the evolution of which accuracy has improved. Approaches. Machine translation can use a method based on linguistic rules, which means that words will be translated in a linguistic way. The most suitable words of the target language will replace the ones in the source language. It is often argued that the success of machine translation requires the problem of natural language understanding to be solved first. Generally, rule-based methods parse a text, usually creating an intermediary, symbolic representation, from which the text in the target language is generated. According to the nature of the intermediary representation, an approach is described as interlingual machine translation or transfer-based machine translation. These methods require extensive lexicons with morphological, syntactic, and semantic information, and large sets of rules. Given enough data, machine translation programs often work well enough for a native speaker of one language to get the approximate meaning of what is written by the other native speaker. The difficulty is getting enough data of the right kind to support the particular method. For example, the large multilingual corpus of data needed for statistical methods to work is not necessary for the grammar-based methods. But then, the grammar methods need a skilled linguist to carefully design the grammar that they use to translate between closely related languages. The technique referred to as rule-based machine translation may be used. Rule-based. The rule-based machine translation paradigm includes transfer-based machine translation, interlingual machine translation and dictionary-based machine translation paradigms. This type of translation is used mostly in the creation of dictionaries and grammar programs. Unlike other methods, RBMT involves more information about the linguistics of the source and target languages, using the morphological and syntactic rules and semantic analysis of both languages. The basic approach involves linking the structure of the input sentence with the structure of the output sentence using a parser and an analyzer for the source language, a generator for the target language, and a transfer lexicon for the actual translation. RBMT's biggest downfall is that everything must be made explicit. Orthographical variation and erroneous input must be made part of the source language analyzer in order to cope with it. And lexical selection rules must be written for all instances of ambiguity. Adapting to new domains in itself is not that hard, as the core grammar is the same across domains, and the domain-specific adjustment is limited to lexical selection adjustment. Transfer-based machine translation. Transfer-based machine translation is similar to interlingual machine translation in that it creates a translation from an intermediate representation that simulates the meaning of the original sentence. Unlike interlingual MAHT, it depends partially on the language pair involved in the translation. Interlingual machine translation is one instance of rule-based machine translation approaches. In this approach, the source language, i.e., the text to be translated, is transformed into an interlingual language, i.e., a language-neutral representation that is independent of any language. The target language is then generated out of the interlingua. One of the major advantages of this system is that the interlingua becomes more valuable as the number of target languages it can be turned into increases. However, the only interlingual machine translation system that has been made operational at the commercial level is the CANT system, which is designed to translate Caterpillar technical English into other languages. Dictionary-based machine translation can use a method based on dictionary entries, which means that the words will be translated as they are by a dictionary. Statistical machine translation tries to generate translations using statistical methods based on bilingual text corpora, such as the Canadian Hansard corpus, the English-French record of the Canadian Parliament, and EUROPARL, the record of the European Parliament. Where such corpora are available, good results can be achieved translating similar texts, but such corpora are still rare for many language pairs. The first statistical machine translation software was Candide from IBM. Google used SYSTRAN for several years, but switched to a statistical translation method in October 2007. In 2005, Google improved its internal translation capabilities by using approximately 200 billion words from United Nations materials to train their system. Translation accuracy improved. Google Translate and similar statistical translation programs work by detecting patterns in hundreds of millions of documents that have previously been translated by humans and making intelligent guesses based on the findings. Generally, the more human-translated documents available in a given language, the more likely it is that the translation will be of good quality. Newer approaches into statistical machine translation, such as METIS2 and PRESEMT, use minimal corpus size and instead focus on derivation of syntactic structure through pattern recognition. With further development, this may allow statistical machine translation to operate off of a monolingual text corpus. SMT's biggest downfall includes it being dependent upon huge amounts of parallel texts, its problems with morphology-rich languages, and its inability to correct singleton errors. Example-based machine translation approach was proposed by Makoto Nagawa in 1984. Example-based machine translation is based on the idea of analogy. In this approach, the corpus that is used is one that contains texts that have already been translated. Given a sentence that is to be translated, sentences from this corpus are selected that contain similar subsentential components. The similar sentences are then used to translate the subsentential components of the original sentence into the target language, and these phrases are put together to form a complete translation. Hybrid machine translation leverages the strengths of statistical and rule-based translation methodologies. Several MAHT organizations claim a hybrid approach that uses both rules and statistics. The approaches differ in a number of ways. Rules post-processed by statistics. Translations are performed using a rules-based engine. Statistics are then used in an attempt to correct the output from the rules engine. Statistics guided by rules. Rules are used to pre-process data in an attempt to better guide the statistical engine. Rules are also used to post-process the statistical output to perform functions such as normalization. This approach has a lot more power, flexibility and control when translating.